Hello, welcome to today's movie. Today's movie will take some time series data and we'll fit a double exponential smoothing model to that time series data, and then we'll use the model to fit what the model would predict and forecast. And in this particular movie, we'll use SPSS. In a previous movie, we used Excel. So a reminder about the Excel solution. And remember, the problem was with respect to the UK birth rate per 1,000 people. So we were given some data. The year 1960, the birth rate was 17.5 per 1,000 people. 1961, it was 17.9 per 1,000 people. And we were given the data up to time point 59, which is 2018, where we had 11 UK births per 1,000 people. And we were asked to also provide some forecasts for 2019, 2020 to 2023, as you can see on the screen. Now, we used Excel. There's our single exponential smoothing equation. There's our double, and there's our forecast equations, etc. And we initially put in an alpha value of 0.05, and that gives us a mean square error value of just over 2 and a root mean square value of 1.4, etc. You can see that when we fitted the model for time point 2, 1961, the model would predict 17.5 births per 1,000 people. And then in 2018, which is time point 59, the model forecast prediction was 11.52. And then we used this equation as well to extend for 2019, 2020. So for 2019, the model forecast was 11.4 births per 1,000 people. In 2023, it was 11.12. Now that was for a fixed value of alpha, and then what we did was you could then optimize, use an Excel solver, the minimization of the MSE number, and therefore the RMSE number, the root mean square error, and what the alpha value would be to give us that. Now we did this. I did the root mean square error simply because SPSS provides that number there, and also would provide that number there. So it uses SPSS would automatically minimize the RMSE number and give you alpha, and then based upon that give you these forecasts. So you can see after optimization, these are the forecasts. So in 2019, 10.62, 2023, 9.08. Okay, so we've got those numbers and we can do a comparison in a minute. So what we'll do is we'll go to SPSS now. There's my data file already input, and these are the future time points listed there. Time point 60 to 64. So what we need to do first, because we've got a time series problem, we need to define the date and time. So we click on data, we click on define date and time. And remember, in this particular case, we're dealing with years. And we're starting at the year 1960. Oops, apologies. 1960. There we are. Now we can click OK. The output file will tell you what you've actually done, and the data is in the data file, as you can see there. Now once we've done that, we can then do the double smoothing average. So we click on Analyze, we click on Forecasting, and then we click on Create Traditional Models. Okay, so there's my time series modeler, menu open. We want to transfer series into dependent variable box. And now we need to tell it what the method to employ. So we want exponential smoothing. Then we click on criteria. Now double exponential smoothing is Brown's linear trend method. Okay, so we use Brown's linear trend method. Click on continue. Okay, then click on statistics and then decide what statistics you want. So let's say we want the root mean square. We want to display the forecasts. Let's go to the plots. So we might say we want some graphs as well. Okay, so we can say, for example, we can have a graph which has the observed values, the forecast values, okay, which is those extra time points down below, 60, 61, etc. The fit values, which is the fit between time point 1 to time point 59. Now you could also ask for confidence intervals as well, etc. if you so wish. Now you can do that in Excel, but it's a bit complicated, but it's much easier in SPSS, as you'll see in a second. Okay, if we go to output file, we don't need save. Now we'll just save these values here, predicted, the lower and the upper. And what it'll do is it'll create 1, 2, 3 extra columns of data. And then once you've done that, we can click on options, and we want a prediction which goes through to the year 2023. So in there, we need to type in 2023. And once we've done that, we can then click OK. So in the output file, it'll tell you what your model fit is. Look, it tells you it's the Brown method. There's your root mean square, 0.341, etc. It gives you the model statistics and it gives you the forecasts. And it actually, you see there, it also gives you your graph as well. Okay, you can do this in Excel as well if you so wish, but it's so much easier in SPSS. If I go to the data file, you'll see, now you can see there I've only got 1 decimal place. Let me just increase the number of decimal places for the prediction. Okay, and you can see there, right, that there's your time point 60, which is 2019. The model predicts 10.61. Now, if you go to Excel and you go to the optimization solution, there we are, 10.62. Now, did I get that right? So it's 10.62 in Excel, and in SPSS, oh, look, it's 10.62 to 2 decimal places. So you get exactly the same solution. So the last one is 9.0766. So it's 9.0. So if I just increase that, there we are. Okay, so it's just slightly out, and that's because of the way that SPSS solves this particular problem. You'll see that our root mean square error value is 0.34, and in SPSS, if I go to the output file, it's 0.34. So it's basically the same value. Okay, just slightly out. Okay, so that's how you use SPSS to fit a double seasonal model, which is Brown's method. Yeah, and also to use it not only to fit, but also to be able to predict, but also to be able to plot your graphs as well, as you can see there. Okay, so that's the end of this movie. Bye for now.